Hi friends, welcome to Easy Learning Economics. I am Dr. Kaval. In the previous lecture, we determined the profit maximizing output for single product using the demand function and marginal cost function, using demand function and average cost function, profit maximizing output using the total revenue and total cost function, and also we determined the quantity using the total revenue function. So in this lecture we are talking about to determine the profit maximizing output of product X and Y, that this is the profit function, and you can see that here is X on the one side and Y on the other side in the equation. So profit function include X and Y. It means the firm is producing the two products X and Y. If you want to know that how can we determine the profit maximizing output by various methods, so please check out the links in the description box. So this is the profit function, that 80x minus 2x square minus xy minus 3y square plus 100y. We have to determine the profit maximizing output for X and Y. So we shall apply the partial derivation in order to find the single product maximizing level of output. This is the d pi over dx. It means this is the change in profit with respect to change in X. We do the partial derivation here. So applying the power derivation rule here, the result is 80 minus 4x minus y. Likewise, we have to apply the partial derivation of y. This derivation tells that how much change in profit is caused due to change in production of X product. On the other side, this derivation is telling that how much change in profit is caused due to change in Y product. And under the total revenue and total cost function, we derive the profit function. Here we have given the profit function, the change in profit with respect to change in X. This is the equation number 1, that is also made equal to 0 in order to find the profit maximizing output. So this is an equation 2. So we have to solve these equations. So multiply equation number 2 by 4, then subtract the equation number 1 from equation number 3. After multiplying the equation number 2 by 4, the result is this, that is 400 minus 4x minus 24y, because that we have to solve for the simultaneous equation here. This is the 400 minus 4x minus 24y is equal to 0, and 80 minus 4x minus y. After changing the sign, that we solve for that 320 minus 23y is equal to 0. After solving it, 320 is equal to 23y, so y is equal to 320 over 23, so y is equal to 13.92 units. It means the 13.92 units of the y output can maximize the profit of the firm. As we determine the y output, 13.92 gives the maximum profit of the firm. So firm is not producing only a single product, the firm is producing the both product X and Y. So in this part we determine the profit maximizing output of X product. So this is the profit function given. To find the value of X, so substitute the value of Y, that is 13.92 in the equation number 1. So this is the equation number 1, 80 minus 4x minus y, we already derived after derivation for y. So after solving it, we will see the value of X. So X is equal to 66.08 over 4. So X is equal to 16.52. So the 16.52 units of X product gives maximum profit to the firm. The firm maximizes profit when it sells 13.92 units of Y and 16.52 units of X. What would be the profit? So we can find the maximum profit if we add the optimum found quantity of product X and Y in the given profit function. So this is the profit function, and putting the value of X and Y here, and after solving it we can see that what would be the maximum profit. That maximum profit is $1,356.523. So this is the maximum profit if the firm produces 13.92 units of Y and 16.52 units of X. I hope this would be clear to all of you. Here I would like to recommend please go through the links given in the description box to learn this video in detail. So if you have any questions, let me know in the comment section. Thanks for watching.